क्या नहीं करने वाले देखना देखो पानी देखेंगे कि तुम तुझे वापस देंगे मैं कर सकता हूँ ले ले भाई क्या यार फरीद का नंबर भी नहीं है मेरे पास भाई फरीद इज द ओनली शॉपिंग हो गए bro you can stand this I'm sorry but he's a nice guy I'm sure very nice here bro we want him the very long and I've known him for a very short time and he's terrible no bro he's very do not call me that stupid thing but is that thing like funny not very nice very annoying but not very nice very annoying nice little bro we want to I'm looking for a very short time annoyed in the life out of me Jesus have heard that we actually talk to him just talk to me over text over text is not annoying ये बता very stupid terrible hey every time you message me you want something you should be right then just page thanks for that little speech I was out of it's okay what please please मेरा मन भी है लोगों को please please ये पैसा भी ले ले please for my friend now no से ज़्यादा तो सबसे दोस्ती है वो क्या हाल है my friend now ये मेरा ट्रिक है एक मिनट है क्या क्या किए देखो बात करने नहीं आनी है वाली वॉच दे मेरे पीछे वाली है कोई पार्टिसिपेट सुधार how to do this Aditi you have next we have extra 10 yeah मेरे को तो ना last word try ना try no तो बहुत बढ़िया है at least this part it is it's just bored one this thing whatever just do it now would not fit how small are your wrist man wrist क्या होता है wrist नहीं bro wrist sounds small 15 wrist I call jalapeno jalapeno actually jalapeno sounds better so very just go to area udri ke lead this jalapeno that's what I said I don't know you're weirding me out with everything you say jalapeno no please shut up jalapeno I like jalapeno I was small I read that packet before jalapeno वैसे knowledge पढ़ा था ठीक है does not knowledge is better something sometimes I spell words when they sound better so I spell it get it no but it's okay don't get it it's okay but knowledge is actually nice it's not exactly the opposite of when you start saying knowledge some people don't have knowledge She's basically on all my stories. Can I have 3 of the assignment? मुझे पहला बार बैठा What the fuck man I never swear it doesn't full me church goers around do not curse you never cursed in your life she's a church goer my love she's a church goer that answers all your questions they can't swear no that's a sin no it is not but I'm a very big sin like even in my church many students curse over there also because I choose not to curse what do you do when you're angry it's I heard you use fudge I'm not saying fudge I said what did I say freak or something fudge or something I freak yeah You're a freaking idiot. Yeah, I've heard you say that. उन्होंने मेरे 4,000 की पेन होता है उसका एक्सप्लेन नहीं करूंगी पूरा करना होता है तो कितने में बात आई ये माइक्रोस्कोपिक हो गई यार और भी ज्यादा आपसे क्वेश्चन भी पूछेंगे सर ये अक्षर तो आई क्यों नहीं दे टाइम से एग्जाम उसके पहले मार थी हां क्या हुआ थोड़ा इंसेक्शन हो गया यार ना ब्रो खा लो you bro you came like when we started the portion and you took a leap and you back from bed and this you चलो बस हां ना मैं देखी हूं ना आई नहीं अभी है मतलब तू अभी पहले आई थी जब पोर्शन स्टार्ट हुआ था अब तू आई जब पोर्शन खत्म हो गया 12 हो गया केमिस्ट्री का पोर्शन पर हमने अभी मंडे एंड फ्राइडे को सिर्फ एक ही मैच करेंगे तो घर ये अभी नहीं जान अरे जेरो सबसे ज्यादा एग्जाम मुश्किल जा रही है नहीं वेरी कॉम्प्लिकेटेड क्या कॉमन सेंस का भाई सो तो वही वैसे एक पर नहीं
Yes, come on. See what happened to it. Huh?
Akshara. No, actually.
Huh?
Your hair is not dyed or what? It just turned from salt and pepper to simply
Yes.
salt.
Because of the tension, you know.
Oh my god.
Yeah. Okay, where did we stop in the last class? Where did we? She is also appeared just now. 1, 2. Last class we had very few students, just 3, 4 of them. क्या हो गया था? एग्जाम चल रहा था? कैसा हुआ?
Nice.
What about you? You were present in the last class?
Yes.
ठीक है. Where did we stop in the last lecture? Where are you?
We were doing work and
Your father told me you're busy with some other activities.
Sir, actually, I was unwell for 1 month. Exam.
Okay, so I think we were doing work, power, energy, right?
work and energy.
Work, energy. And which topic you were discussing last?
We did, I guess, kinetic energy last.
Till kinetic energy.
Yeah.
We derived the expression.
Yes,
Huh?
yeah.
Okay. So those who have missed the lecture, so what we have done is we have defined what is meaning of work. So work basically is
Work is said to be done by the force acting on the object if it displaces the object in its direction.
yes. So this is the formula. W equal to F dot S. Dot means product. Okay. And a more general formula is F dot S cos theta. Did I tell you about this?
No.
Okay. So we'll discuss that. Then we discussed about what is meant by positive work, then negative work, and zero work, no work. We discussed all this. When the work is said to be positive,
When it is working in the
so understand it with this example. Suppose this is the body and force is applied on it in this direction. If the force displaces the body in its direction, then the work is positive. Force applied and the displacement caused in the body is in the
Direction of the
same
force
direction.
applied.
Yeah, same direction. Which means what is the angle between force and displacement? They are parallel, right?
Okay, yeah.
So what is the angle between parallel lines?
So 90.
90 degrees.
Wow. Make us so proud. Parallel line 90 degrees.
There is, I'm pretty sure. How can we get this
No,
answer
sir, it
between
is
parallel lines?
Achha sir, 180 degrees.
Then what is this?
180.
This is 180. What is this?
360.
Zero. Who said zero?
0.
Zero. Parallel line.
Sorry.
Does it have any angle?
No,
Yes.
Now it has angle. 90, 180, 270, 360. Full circle, right? So between two parallel lines, the angle is zero.
Zero.
So this is called theta. It symbolizes the angle. Or when force and displacement in same direction, or theta is equal to 0 degree. Theta is angle. Theta is,
Why does
Theta.
theta look like a cube?
it's not Q, it's O.
Oh,
Oval O with a cut in between. Theta is angle between F and S. Okay, this is what it is. Negative work means when this body is going on the right side, where is friction acting on the body? In the opposite direction, right? Friction always act in the direction opposite to motion. So what is the angle between S and F now? 180 degree, right? So work is negative when theta is equal to 180 degree. That is F and S act in opposite direction. Then the work is said to be negative. Then zero work. Work is said to be zero when theta is 90 degree between F and S. So for example, if a person is keeping some weight on his head and say walking in this direction. So what is the weight direction? Downward. What is the displacement? 90 degree. Okay, so in this case, no work is done. Got it? So zero work done. Or if the object is moving in the circular motion, circular path, then the displacement is always 90 degree to the centripetal force. Okay? Like moon revolving around earth. So earth does no work on moon whenever the object is making circular motion. So angle theta is 90 degree in this case. Okay? So basically you have to remember, so cos 0 degree is 1. Cos, the value, you will learn about it in mathematics. Cos 90 degree is 0. And cos 180 degree is -1. These are the values. So this will tell you, depending upon the angle, the work is positive, negative, or 0.
Zero. Theta going to zero.
It's
Okay, so we have seen three types of work. Yes.
What is cos?
I was wondering why nobody asked me that.
Sir, cos theta is present in trigonometry.
Yeah, but what is it?
She still knows more than us.
Cos is used in trigonometry. What is trigonometry?
Sir, it's basically the measure. It's related to something geometry and a trig.
Yeah.
So
basically-
poles,
There you go.
triangles, 90-degree triangles.
So trigonometry is study of
Right angle.
sides and angles of triangle basically. There you go. So if it is a right angle triangle, okay, let's name their sides as A, B, C. Who asked the question? What is cos theta? You. Okay.
The theta involved in the cos.
Huh? Theta is just a symbol. It could be alpha, beta, gamma, theta, beta, alpha, gamma, like that. These are Greek letters.
Sir,
Okay?
there is symbol for similarly also.
Yeah, which is this. There are so many symbols. So take it as it comes. So what I was trying to say is sine theta is the ratio of perpendicular AB. This is called the angle opposite. Okay? The side opposite to the angle, which is not 90 degrees. That is called perpendicular. So AB is perpendicular. This is called base. And this is called hypotenuse. Hypotenuse. Okay. Now, this relation, the ratio AB upon AC is called sine theta. Okay, that is perpendicular upon hypotenuse. And this relation, this ratio, cos theta is equal to base upon hypotenuse, which is BC upon AC. Okay, and tan theta is AB upon BC. But this is called tan theta. So these are relation or ratios of sides of right angle triangle. So it is AB
Sir,
upon.
what is it used for? Study of right angle.
It is used to calculate the distances. You will come to know.
You're looking from this
Sir,
and
it's
that.
under-
Yeah, I've seen my sister solve this.
Yes. Huh?
That's under the successful members of trigonometry.
Not just trigonometry, so many things. It is successful about the rocketry, the science, physics, the gravitation laws.
Yes.
Right?
You missed when we sat for the Chandrayaan launch.
Yeah, we yes, we
I
saw
saw
it.
it and
You were home alone, but this was like very buzzing environment.
so my cousin was screaming and all.
It was like watching cricket match.
Actually, not
Only when we
everyone.
see cricket match, that kind of environment is created.
Not
Right?
everyone, actually, there was only one specific boy who was.
That was Neeraj, right?
Yeah.
Sitting in. Okay, so basically all of them have various values, so on and so forth. So basically sine values, there is a way to calculate that you will learn in maths, right? So just these two, I mean, remember the value for sine theta. Like sine theta is 0, sine 0 degree is 0, sine 30 is 1 by 2, this is 1 by root 2, root 3 by 2, and 1. Okay? And cos theta is just reverse of this. So start from 1, root 3 by 2, this remains same, 1 by 2, and 0. These are the values. Okay? And then tan theta is, what is tan theta? AB by BC. How do you get it? Just take the ratio, sin theta by cos theta. So take 0 by 1, 0. This divided by this will be what? Root 3, 1. Then 1 upon root 3, right? This will be 1 upon root 3. And then this is root 3, and this will be infinity. 1 divided by 0 is infinity. Okay? It will be taught to you, I think, this year or 10th standard. Okay. So what we are doing is we are remembering only these values, and there is one for 180 degree. Of course, you remember it as.
Sir, we will learn it in entrance also.
Huh?
Sir, engineering entrance also, I think it is there.
This is just not even a child for engineering entrance. Much higher level is there. This is just the introduction. Tilling the soil, and entrance is like a fruit bearing tree. It's not scaring, and the good thing is everybody does it. Alright? So that's the good thing about it. Everybody does it, right?
Yes, sir.
Because there is no choice. Alright. So that's why 9, 10th, 11th, 12th, these are defining years of your life and career. Alright. So this is, I'm telling you about what we have done already, right? So we did this about work. Then what did we do?
Energy.
This is all about work. The next topic was energy.
Energy is defined as the ability to do work.
Yes. So
Yeah,
We
revise.
started energy also.
No, we are just revising everything that's.
Yeah, ability to do.
so what is energy? It is ability to do work, right?
Then we have
Ability.
defined mechanical energy.
Yeah, ability or capacity to do work. Okay? Meaning if you want to do work, you got to have energy, right? Means, so what else it means? When work is being done, energy is lost. So whenever any body does work, it loses energy. And reverse is also true. If you work on a body, it gains energy, right? So we use that to basically derive the. So I'm erasing it. You don't need to worry about it too much. Just remember these values. Cos 0 is 0. Cos 0 is 1. Cos 1 it is minus 1. Cos 90 is 0. Just remember these things. Only 2 boys in this class.
And both did not show up today.
I have also counted 3. So 2 of them have discussed. Why? Exam going on?
Bhavya has no exams, neither does Anurag. Unke exams khatam.
I think
So
they
we are
didn't
having
check the
good time.
timetable.
Huh?
I think they didn't check the timetable.
Possible. Okay, so energy is capacity to do work. So energy mein how many types of energies are there? So many, right? Like light, heat, sound,
Mechanical,
then mechanical.
electric,
Yes, electrical से पहले chemical करो.
chemical, electrical, and nuclear.
Yes, these are the 7 types of energy. Out of all and these energies can be converted from one form to other. It's possible,
Yes.
right? Heat anything too much, फट जाएगा वो. फटेगा ना? है ना? When you burn wood, what happens? Starts burning and starts making sound. Chak chak tak tak kalak kruk सब होता है. So anything can be converted into any, right? And what is mechanical? It consists of 2 parts: kinetic energy and potential energy. Now we are discussing this kinetic energy. It's also symbolized as Ek and this as Ep. And mechanical is total of this. So we call it E is equal to Ek plus Ep. That's what we call. Okay. So total mechanical energy is Ek plus Ep. Right. Now what is the unit of work and unit of energy? Unit of work is joule. Okay. Unit of energy is also joule. Because they are interrelated. Work and energy are interrelated. You do work, you lose energy. Right? Work is done on you, you gain energy. So how can you correlate? By having same measurement. Okay. Now formula for kinetic energy. What is it?
Ek equals
Half
mv square.
So Ek is equal to half mv square. How did we get it?
There's a whole derivation to
There
it.
is a whole derivation to it. So I told you, you gain, the body gains energy when work is done on it. So let us say we have some body here, right? And some work was done on it by applying force F. Let's say it moved by displacement S. Okay? So the kinetic energy is, and we defined what is kinetic energy. It is the energy associated with the body by virtue of
It's motion.
its motion, right? So any moving body will have kinetic energy. So therefore, let's define, therefore, we must say that kinetic energy is equal to work done on body on the body. Right? To reach, to change its velocity. From u to v. Let us say it was initially moving with velocity u. Now if the force acts, force will cause acceleration, and acceleration will cause change in velocity. So if the force acts over this displacement, then it will have a new velocity v. Okay? So this is position A where it started. Now this is position B. Clear? So what is work done? So work done must be force into displacement of the body, right? And let's say the body's mass is m, so force will be m into a by Newton's second law of motion. And by third equation we'll get what? Minus u square upon 2a. What will get? Displacement. Correct? So now what do we get? So a gets cancelled. And we get this expression 1 by 2
M into V
mv square minus 1 by m into mu square. This is the so basically work done on the body, right? So you should write it like this: Ek is equal to work done. That is इसको ऐसे ही रहने दो. Therefore, W is equal to वैसे ना. Both are same. ठीक है? So this is the relation we get. But what is half mv square? This is the final kinetic energy at position B, and mv square must be initial kinetic energy because the body was initially also moving. So therefore, work done is equal to change in kinetic energy, which is equal to k final minus k initial. ये आता है फॉर्मूला. ठीक है? So if the body was initially at rest, then it will only get final velocity, है ना? So if u was equal to 0, then Ek is equal to half mv. So one is change in kinetic energy. It can also be written as our W is equal to change in kinetic energy. So it's actually called as work energy theorem. It's not mentioned in the book, but that's what it is known as. So she was absent for one entire chapter, I think. More than that. Okay, so till here we had done in the previous lecture.
Yeah.
Now let's begin with expression for. Did we derive expression for potential energy?
Yeah,
Did we?
potential energy is defined as the energy processed by the particles.
We did that also. Okay. All right. So it is the energy possessed by a body by virtue of its position. So for you, the potential energy is gravitational potential.
We did this also.
Yeah.
Okay. So how is it defined? So it is the work done in moving a body or displacing a body against gravitational force. Okay. So let's say we lifted a body by a height h, right? So now it has energy. How much force you have to apply? Minimum mg. Minimum force should be equal to the weight of the body to overcome or lift the weight. So what is the work done? So potential energy EP is equal to done in raising a body against gravity. So therefore EP is equal to how much? F into H. Right? So F and the vertical displacement is H. So this will be minimum force you have to apply is mg and this is H. So this is the expression for potential energy. Did we do conservation of energy?
No.
Okay. So till here,
We were gonna start with that.
yeah. So till here we did in the last class. Okay. So kinetic energy is energy possessed by the body by virtue of its motion.
Yeah.
Any moving body will have kinetic energy, and this is the energy possessed by the body by virtue of its position. Okay. So I'll demonstrate it. Okay. Are you done writing? Now see, this object, does it have any potential energy right now when it is kept?
Yeah, it does.
It has. With respect to this surface, does it have any height?
No.
No. So now I work on this body. I lifted it.
How it does
It has, right? See, because now if there is a nail and let's say it is a hammer, and if I leave it, then it will drive the nail into the table. So it will work. The potential energy stored in the hammer will drive the nail into table.
Sir, but instead it is also possible that the nail goes inside.
The nail was.
The nail goes inside it if it is too sharp.
it.
Sir, if it is kept.
Yes, if it is kept upside down, the nail will go inside it. Right? But for the nail to go inside it, it has to jump over it.
Yes.
Okay? So that is when it is, its potential energy is now reducing and it is getting converted into kinetic energy. Got it? So let's now move to the next topic, which is conservation of energy. Everybody has written it, those especially those who were not present in the last lecture.
Yes, sir.
Okay, so now we are starting a new topic, which is conservation of energy. So what is meaning of conservation of energy? Law, or rather it is called law of conservation of energy. What does it mean? And there's one more thing I wanted to tell you. I'm lifting the body straight up, right?
Yes.
If I would have lifted it like this, will the energy would have changed?
No.
Huh? Yes or no?
Yes. Yes, sir.
Yes, sir.
No. What you see is only the straight
Height.
difference, straight height. It doesn't matter which path you have taken. If you have lifted the body little here, like if it was a staircase, then also, as long as the height is same, the potential energy will be same. So it doesn't depend on the path. Here it is straight, here it is inclined, here it is steps. So what is important is just the height, vertical height. Okay? So keep this in mind. Potential energy only depends on vertical height or displacement. What is the displacement with respect to ground? The shortest distance from the ground. Okay? So that's what you need to keep in mind. Next is law of conservation of energy. So what it means is energy cannot be created nor be destroyed instead it can convert, or it only converts from, it only converts from one form to another form. It can only convert from one form to another form. Okay, so energy cannot be created nor be destroyed. Instead, it can only be, or instead छोड़ दो उसको कॉमा लिखना है. It can only convert from one form to another form. Let us understand it. So we'll understand it with the help of an example. Right? So verification. Or a freely falling body. So let's verify this law that it indeed is the case. Okay. So consider there is a object which is falling from certain height. Let that height be h. Okay. So let's say the top position we call as A. So in between it will come to some in between position, right, during the fall. That is position B. Right. And then it will hit the ground. So when it hit the ground, we are calling that as position C. So let us say B is at position X from the top, and at the top its velocity will be 0, right? When it was just dropped from the top. क्या हुआ? नहीं दिख रहा है. So at the top I am saying the velocity is 0, so VA is 0. When it is dropping in between, it will pick up some velocity. We'll call that velocity as VB. And just before it hits the,
U because it is the initial velocity.
so I'm calling it VA. Position ABC. Velocity at A is VA.
Okay.
That is the initial velocity.
Okay.
So U is equal to VA. And here we will call it VC. Okay. So what is VC?
A final velocity.
Final velocity just before hitting the ground. Just before hitting the ground. Okay. So now what we want to calculate is, we want to calculate the potential energy and kinetic energy at these points, and also find the total energy at A, B and C during the free fall. Let's find this. So E will be, what will be E? EK plus EP. And what is EP found out as mgh, and EK is half mv square. This formula you have to use to find the velocity, find the energy at respective locations. Okay. So now so what is the potential energy at the top? Or rather start with kinetic energy. What is the kinetic energy at the top? Half m0 square. So this will be 0. What will be potential energy at the top? What does it depend on? Only height. So what is the height at the top? H. Yeah. From the ground, whenever you are talking about potential energy, you have to, it will depend upon its height from the ground. So what is the height? H. So this will be mgh. So what is total energy? Mgh plus 0, right? Mgh
Plus 0.
which is equal to mgh. Okay. Now let's say some intermediate position B, right? When the ball is at position B during the fall. So at the top we have written here. Now what is the potential energy here at B?
No. Potential energy.
At this position. What is the height of B from C?
H minus X.
X. Very good. So the height is H minus X. So potential energy always depends on the height. Okay. So even though it is X distance down from the top, but its height is H minus X. So what it will be now? Mg H minus X. Okay. This is the potential energy.
Yes.
What about kinetic energy here? So how much is Vb now? So Vb is equal to, so V square is equal to Va square, right? Plus 2GH, correct? Square root of that. Isn't it? So V will be square root of this. Which is what? Which is equal to, because Va is 0. This will be square root of 2GH. So this is what is the value of Vb by third equation of motion. You understand?
Yes.
This is the final velocity, this is the initial velocity. So Vb square is equal to Va square plus 2GH. So Vb will be square root of that. So we get Vb as square root 2GH. So what is the kinetic energy? Half m V square will be, the root will go 2GH. Okay. So what do we get? This gives us mgh only again. Yeah?
Yeah.
Are you with me or no?
Yeah.
This is square root ka square, so it will be 2GH. So again, so what is the total energy now? So it is mg h minus x plus, sorry, is it h? How much did it travel from the top? X, not h. This will be x.
GX.
Yeah.
What
So-
if it be
so
H
this-
minus X? Okay, I'm
No.
confused now.
H minus x is the height.
Yeah.
But how much did it travel from A to B?
Okay, that
X.
is X.
X, yeah. Displacement traveled is only x. Because it picked up speed with respect to A, right? So 2gx and this is x.
So I'm not understanding anything.
It's great.
Like the calculations for the second one,
Floored you.
it is, I don't know.
Yeah, I know, but. So this is mgh. I will explain, don't worry.
Yes.
So this is mgh. So at B position also the total energy is mgh. And it was at A also. So in going from A to B, the total energy does not change. That is conservation. But it has changed. Initially there was no kinetic energy. The total energy was only due to potential energy. During the fall, the potential energy decreases and the kinetic energy increases by same amount. Whatever is the decrease in the potential.
Okay.
Okay?
Yeah.
So that is the change of energy from potential to kinetic. Total is conserved, same.
Okay, that it becomes manual.
Yes. Okay, don't worry about the calculation. First to understand the logic.
Yeah.
I'll explain the calculation. Now tell me what is potential energy at the ground?
Potential 0.
You just speak for others all the time. Change your habit. She says 0. Do you agree?
But we're taking potential energy like the energy like just before hitting the mountain.
Yeah.
So how could it be zero? Because we're taking just
What is the formula for potential energy? It's written twice. What's the formula? mgh. So what's the height at the ground?
zero.
What's the height at the ground?
The height at the ground is
Height is above the ground. What's the height on the ground?
zero.
Obviously, right? So mg is the weight of the object. So mg into 0 should result into
Zero.
right. So mg into 0. So this time it will be mg 0. So this is 0. We are only substituting the value of height at different locations. Now, what about the kinetic energy? So what is Vc now in this case? Like here it was 2gx. Now x is full h. It has traveled how much distance? H. So what will be speed here now? 2gh. Okay. So now when you substitute half mv square, so v square में root निकल जाएगा और ये 2gh आ जाएगा. So this will be half m 2gh. So this is again mgh now. Okay. Now see, it is reversed now. At the top you had potential energy,
And at the
kinetic was 0. And at the ground, potential becomes 0. Full potential energy is converted into kinetic. That is what is the law. So nowhere energy is lost. Okay, of course we have assumed there is no energy lost due to air friction. Because ball will be heated up due to air friction. So some energy will be lost. So we are assuming there is no energy lost due to friction.
How does that happen?
It happens all the
What
time,
is
right?
air friction?
Huh?
What is air friction?
Air friction is. Do you have a loose paper? Do you have a loose paper? Pass it on. Bad pass. Bad pass.
Was that air friction?
Okay, now see. Look here.
Yeah.
How is it falling? Right?
Fell directly.
Fell directly. Okay. Same height, huh?
Exactly.
Are they reaching? Are they reaching at the same time?
No.
This is air friction. Air is, so this is big surface area, right?
Yeah.
This is a small area. So it is, air is not able to resist the pen, but it is able to resist lighter objects.
That's why the feather takes longer to.
Yes.
Kite.
Yes. So air will be able to affect lighter objects, not the stone. Not the stone, right? Okay.
That's also like when you go for parachutes.
Exactly. So parachute, so it's much wider area. But if you just jump without a parachute,
You die.
so our feet area is very little. But for our body weight, that feet area is not sufficient. So
Or
air,
if we fall like this, like all later.
few seconds later, but still won't save you. Okay?
That's the
So you need a large area for the air thrust, up thrust, buoyant force into air to be effective. So large mass of air will be needed. We are a condensed matter. Air is like spread out mass. So density of air is less than us. So therefore we will require large volume of air to be able to equal to our mass. You understand? So that's why. But heavy object and lighter object also reaches at the same time. But in this case, the air resistance is not able to resist it. That's why. But in this case, it does. Okay. So in vacuum, both pen and paper will reach at the same
Same
time.
time.
So have I answered the question?
Yeah.
So here, air resistance, it let you reach you. Let it reach you, okay. So just pass it on. Was it important?
No.
Okay. Now have you understood this calculation? How we got the value of V?
It's okay.
We'll see that later. Huh? Have you understood the calculation? Anyone who want to know how to arrive at V value at B and C?
Yes.
Of
B.
You were saying no, I didn't get the calculation.
yes, for
sir.
that.
Still.
Yes, sir.
Okay. So let's see how the calculation is achieved. So there is a relation, you know, that V square is equal to U square plus 2AS, right? S is displacement. So for a vertically falling body, this is the ground, okay? Let us say this distance is H. So what is V at the ground? So U here is 0. So V at the ground will be V square is equal to 0 plus 2. Now A becomes G, vertical. And S is equal to H. What is the vertical displacement? H. So what do we get? V square is equal to 2GH. So what is V then? So what's the big deal? You've done so many questions like this. Okay, I've calculated for S equal to H. Now here, from A to B, S is X. That's the only difference. Okay, so for here, let's say this distance is only X. So S is X for this value, but for the entire thing it is H. Okay, so that's all. So what's the learning here? The learning is, so I'm writing here the learning conclusion. So what did we wanted to achieve? Verification of conservation of energy for a freely falling body. So is the energy conserved at all locations?
Comes 3%
Is the energy conserved during the free fall?
Yes.
Everywhere it is mgh. But there is a transformation from potential energy to kinetic energy. So totally converted when it hits the ground. During free fall, of an object, at the top, it only had potential energy. At the bottom, it had only kinetic energy. It had only kinetic energy. And in between, it had both potential energy and kinetic energy, such that the total energy at top, bottom, and in between remains same or conserved. Okay. Hence, law of conservation of energy is verified for a freely falling object. Okay, so I hope it is clear. Because energy remains same, total energy. So we say it is conserved. At the same time, we are saying it is changing from potential to kinetic. Yeah? So that's what it is. Alright, so that's about potential energy. So potential energy, so this is just one example of gravitational potential energy. Right? There are certain other examples like change of configuration. Like configuration, like whenever you change the state of the body, like spring, in its natural relaxed state, it has no potential energy. But when you stretch it, now when you leave it, then it has potential energy. Because you did work in pulling it. That work is stored in the spring as its. Even when you squeeze it, yes, both ways. Because you are squeezing it against the restoring force of the spring. Or you are pulling it again. So restoring force changes direction, just like frictional force. When you change the direction of motion, the friction acts in opposite direction of motion. It happens automatically. Okay. So then we have potential energy in case of spring also, or in case of bow, when you pull the string of the bow. Bow, yes. And the bow, when you keep the arrow on the stretched string of the bow, then that potential energy of the stretched string will become kinetic energy of the arrow when you release it. Okay, so that's all. So energy was created in the process?
Yes.
No.
It was
You worked, so no. You worked, so you lost energy. That energy became potential energy of the stretched string of the bow.
And when you leave,
When you
it
release,
becomes kinetic energy.
becomes kinetic energy. Then it hits the atmosphere. It undergoes friction through air. So air got heated. And that's the degraded form. That energy is lost in the atmosphere, means it is not lost. It heated the atmosphere and got dissipated.
So basically, if the arrow
So
does not hit
atmosphere's
anything,
energy increased finally. Yes.
if the arrow does not hit anything, the energy is in the atmosphere. Like if it just lands on the ground.
Yes. So if it lands on the ground, obviously it will produce sound
Sound.
and it will heat that place also. Like hammer hitting the metal will heat it up,
Yes.
produce sound, produce light. So all the energy is transformed into different forms. It is never lost. Okay? So that's the law of conservation of energy. Now with this we reach to the last point of this chapter, which is rate of doing work. Yeah.
What's the in between, bottom and in between?
Bottom and in between remains same or conserved. So in the next class we'll be able to finish the chapter. After that only sound, right? Just one more chapter remaining.
Yes.
Okay. So I gave you one example of freely falling body. Let's discuss one more example of a oscillating pendulum. Conservation of energy of an oscillating for not of for an oscillating pendulum. So everybody understand what is a pendulum,
Yes, sir.
right? So you must have seen a oscillating clock pendulum.
Yes.
So any heavy metallic bob suspended through a string like this forms a pendulum. So now when you, right now it is its mean position. This is a mean position. Mean position. So it will not oscillate if it is left at its main position. So now if you move it on one side, so did you do any work?
Yes.
Yes, we applied force and displaced it. So whatever work we did on it, let us say it comes here at this position. Okay. So if you imagine this was horizontal position, so how much height is increased? Let us say the height increase is h. So what energy will it have? Let's call this point as A, this as B. And when you leave it, so it will reach on the other extreme. And this we are calling C. Okay? So it will go from here to here. So this is its path during oscillation. Right? This is how it will oscillate. So what is the energy now at A? At A, what is the velocity? It is the top position, right?
Yeah.
So at top, is there any velocity?
No.
No, because it will now change the direction. So just before changing the direction, its velocity will be momentarily zero. So V at A is equal to 0. So what is kinetic energy? EK is 0 because V is 0. What about EP? Only vertical height, so mgh. So the total energy here is mgh. What about this point? What is the height here now?
0.
Height 0. So potential energy is, so EP at the mean position is 0. Then what should be EK? Yes. The entire potential energy by conservation of energy will convert into mgh. So this will be half mvb square, and this must be equal to mgh. So how much will be vb? Therefore, vb is equal to, at this place, is 2gh. So at B you have vb equal to 2gh. That's why it will have kinetic energy mgh. Understood? So this is what it is. At this place again it is same. So here EK is 0. EP is mgh. Right? Because it's the same H. Understood? H is basically baseline. Don't take next year. From the base. This is H. So this is conservation of energy in case of oscillating pendulum. So where is the energy different at ABC? So total energy at all the location is same. And here also total energy is same. So only potential is changing into kinetic. Huh? So at B it has only kinetic energy. At A and C it has only potential energy. Okay. In between it will have both. Okay. In between B and C, from C to B it will have both. So potential energy will reduce and kinetic energy increases. Where is maximum kinetic energy? At B. Maximum potential energy at
C
and
A.
ठीक है? समझ आ गया? So energy is only converting from potential to kinetic energy, and total energy remains same. So that is conservation. ठीक है? We'll see power in the next class.
आज शाम को बोलना है ना छुट्टी के लिए।
किसने नहीं किया है करो एक बार।